Hello everyone. So today we're going to be learning how we can convert a PDA to a CFG. So as you might be aware that PDA refers to a push down automata and CFG refers to context free grammar. So what a push down automata does is that it is an abstract machine. It is an abstract mathematical model which accepts context free language, which is made up of context free grammar. So for context free grammar, we have four tuples to define a context free grammar and seven tuples to define a push down automata. So today in this video we're going to be learning about how we can convert a push down automata, which is a seven tuple machine, to a context free grammar, which is a four tuple model. So today we're going to be exploring that. So first of all, let's understand how a push down automata works. A push down automata, usually defined as M, has seven tuples as we just discussed: K, sigma, tau, delta, Q naught, Z naught, and F, where K denotes the set of all the states, sigma denotes the input alphabets, tau denotes the set of stack symbols, and delta denotes the transition functions. Q naught here is the initial state of the PDA. Z naught is the initial stack symbol, and F here is the final state. It is the ultimate symbol of acceptance by a PDA. So if a string is acceptable by a PDA, it is going to end at the final state. So basically how PDA works is that there's a stack. We have already learned about stack data structure in our previous videos. And in this stack, we keep on, as the name suggests, pushing something down into the stack. So this is how a base plate here has a Z naught, which is an initial stack symbol. So there's a base plate and then we push on the symbols onto it, and then if the final state is reached by this automata after popping out and pushing out all the symbols, we can say that this is accepted by the PDA. So now we are going to convert this PDA into a CFG. CFG is a four tuple, usually denoted by G, and the four tuples are N, P, P, S. Here N refers to the non-terminals, T refers to the terminals, P refers to the production rules, and S refers to the start symbol. So here we're going to learn how we can convert this seven tuple that we are given in this question, as you can see here. Here this is the K, sigma, tau, delta, Q naught, and Z naught. And the F is an empty state, which basically means that if our stack is empty at the end of our entire conversion, we get to the point that okay, this is the final state, and if this stack is empty, that is the ultimate symbol of acceptance for our language or for our string. So this is the PDA that we have been given here, and these are the transition functions, as we can see. So one thing that we can infer from this PDA that we have been given here is that these two, you can see in this transition function, there is a Z naught plate first, and then there's something being added on to this Z naught, which is in essentially an X, right? Then we also have this one more transition function where X is the given base plate, and again something else is being added on to this X. So these are all addition functions. So when we push something into a stack, and when we are adding something onto the stack and on top of the stack, we call it a push function, right? So we can infer from these two transition functions that these are corresponding to a push function. Now for these four, the one thing that we see in common is that x, epsilon, x epsilon, x epsilon, and z naught epsilon. So the output function in these transition functions is all corresponding to a null, which can be visualized as there is a plate on top of the stack and then there is no plate. So when we are taking something which is existent into the stack and then all of a sudden it becomes non-existent, what do we call it? We are essentially deleting that, right? So this is a pop function. So these four are the pop functions that have been given to us, and these two are the push functions that have been given to us. And this is how we can finally start making a CFG out of our PDS. So for defining a CFG, as we have already seen, the four things that we need to define as non-terminals, terminals, production rules, and start symbol. So the first thing we have in our solution is, let's start by defining a start symbol. So start symbol here is Q naught, Z naught, Q naught, and Q naught, Z naught, Q1. Why is it so? Because these two are the start symbols for the set of states, and these two are the initial stack symbols, and this refers to all the states that can be achieved in with our PDA. So these two are essentially the start symbols for our given PDA, right? So we have already defined our start symbol. Now let's move on to our set of terminals. These are pretty obvious and they've already been given to us. These are our input alphabet. So our terminals here are 0 and 1. Then the next thing that we are going to be defining here are our terminals. Are our non-terminals. So our non-terminals are basically the ones that do not terminate immediately after just inputting a stack symbol or something. So we need to extend that into a terminal, right? But a non-terminal here can be defined in the following ways. So let's start by naming these non-terminals, right? So first our non-terminal would be Q naught, Q naught, Q naught, Q1, Q1, Q naught, Q1, Q1, then again Q naught, Q naught. So as you can see, we are basically making up all the possible variations and permutations and combinations of all the possible states that we have, and we are basically turning that into our non-terminals. So Z naught, Z naught, Z naught, Z naught, X, 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 and X. So here we have all these non-terminals and we are going to name it for our simplicity and for the sake of our organization. So A, B, C, D, E, F, G, H, right? So these are our non-terminals. So we have already defined these non-terminals. Now let's move on to our production rules. Now these are the most important ones that we are going to be doing. So our production rules are the main part of our CFG. So the first thing that we are going to be tackling here is our push functions. So when we define our push functions, we can see from here that there are two push functions. So let's write them down first. This is delta Q naught 0 Z naught, then delta Q naught 0 X is equal to Q naught X Z naught and Q naught X X. So here are our push functions, and we can see from our push functions that we need to first define how these are being pushed. So let's start by defining our push functions. Q naught, Q naught, Q naught, Q1. Then there is Q naught, Q1, and Q0, Q1. So these are our start symbols. Now again, we are going to define them for Z0, Z0 and Z0. And now for our X symbols, right? For this productions. So this is the base plate, and for this one production, we have defined these four rules. We are going to extend it further, but let's start with this. Then X, Q0, Q0, X, Q0, Q0, X, Q1 and Q0 X Q1. So these are our 8 production rules for our push symbols, and now let's start extending and defining them. This goes 0 0 0 0 0 0 0 0. Why? Because these both input symbols are 0. So we are only defining a push when there is a 0 input signal, when there is a 0 input symbol, and we are basically trying to make two more tuples out of it. So let's define those two tuples. Let's do the manual work first. And yeah, so for these tuples, we are going to follow a particular pattern which needs to be remembered. But once you get used to this pattern, you are not going to find it very tedious. At first, it might look like a big obstacle. So it goes Q naught, Q naught. These all go here, and these all go here. Let's start by doing it. So these are all Q naught, so it's pretty easy. Q naught, Q naught, Q naught, Q naught, Q naught. Here it is Q naught, Q naught, Q1, Q1, Q naught, Q naught, Q1, Q1, right? And for this is our tuple of 3 variables and 3 parameters. So let's define that first. And yeah, so 1 2 3 4 5 6. Okay, so here we have, now we're going to start alternating these Q naughts and Q1. So Q naught, Q1, Q naught, Q1, Q naught, Q1, Q naught, and Q1. And here as well, Q naught, Q1, Q naught, Q1, Q naught, Q1, Q naught, Q1. This might seem a little overwhelming, but it all reduces and simplifies down, so it's not that big of a deal. Now here we can see, let's start by defining X and these output function rules out of the transition functions. So as you can see, first X is coming, then Z naught is coming. So let's start by defining these 4 by X, Z naught, X, Z naught, X, Z naught, X, and Z naught. And for these 4, where X is our input function, we start by defining X, 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 and X, and X. So now that we are done with all of our push functions, we can also reduce them down further, but let's keep it like this for now. Now let's start defining our pop functions. Pop functions are really easy to design and to implement. So our pop functions, as you can see from this, are Q naught 1 X going to Q1 and epsilon. So first of all, let's take all of these and move them down here. So we can very evidently see what are our 4 pop functions from here, and out of these we can define the 4 pop production rules as well, right? So for defining our pop production rules, we should refer to these pop rules all the time, which leads us to these pop production rules. So Q naught X Q1 leads us to 1, right? Q naught X Q1 leads us to 1. In this entire fashion, we're going to design our pop function rules as well. So Q1 x q1 leads to 1, then q1 x q1 leads to epsilon, and q1 z naught q1 leads to epsilon. So we have all our 4 pop function rules defined with us again, so that now we can take a very good look on all of our production rules that we have obtained. This is the unsimplified version, so it's a bit difficult to interpret all of it, but now we're going to simplify them as well. So for simplifying these functions, we are going to first have a look at what all functions are essential. So for the starting of our entire function process, we are going to start by thinking that okay, all of these are essential ones. The start symbols are essential ones, and these are also essential ones. So whatever production rules don't contain these in their second half will be termed as useless, and that entire production rule will be termed as useless. So first let's start by defining what all are our non-essential rules. So let's refer to these, and then let's refer to these in order to figure out which ones are our essential ones. So q naught x q1 leads to 1. So q naught x q1 is an essential. So we can see q naught x q1 is an essential one. So q naught x q1, where do we find q naught x q1? Q naught x q1 is f, so it is an essential one. Then we have q1 x q1. q1 x q1 is also an essential one. Then q1 z naught q1 is also essential. q1 z naught q1 is also essential. And yeah, so these are our pop functions. Then we have our push functions. So q naught z naught q naught and q naught z naught q1, q naught z naught q naught and q naught z naught q1, both essentials. Q naught x q naught and q naught x q1, these are all essentials. So the only non-essential ones are q naught z naught q naught and q naught q1 x q naught. So now let's start by removing these. All of the functions that have this in their second half will be considered useless. So q1 z naught q naught, q1 z naught q naught, this it's here, so it's useless. Then q1 z naught q naught, again let's search for that. Okay, so there's nothing with q1 z naught q naught here. So yeah, I think we're safe. Then let's move on to q1 x q naught. q1 x q naught, q1 x q naught is present. q1 x q naught is present here. This is a wrong one. So this is also considered something not right, and this is useless as well. So q1 x q naught again. q1 x q naught. Okay. So we have finally come to the conclusion that these two symbols are useless. Okay. So now we are left with these symbols and these symbols. So these 10 production rules: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's simplify them. This was a preliminary stage of simplifying our functions. So q naught z naught q naught refers to q naught z naught q naught refers to a. A goes to 0. q naught x q naught. q naught x q naught is e. q naught z naught q naught, which is a. And since this is useless, we are going to move on to our b. which is Q naught Z naught Q1 goes to 0 Q naught X Q naught, which is A. Wait, it's Q naught X Q naught, right? So Q naught X Q naught is E. And then we have Q naught Z naught Q1. Q naught Z naught Q1 is here, which is B. And there's also one more production rule for B. Q naught X Q1, Q naught X Q1, which is F. And Q naught X Q naught Z naught Q1 Z naught Q1. So Q1 Z naught Q1 is D. So these are the two functions that we have for B. So Q1 Z naught Q1. Okay, great. Now let's move on to our next production rule, which is we are done with this pop function. Now Q naught X Q naught, which refers to Q naught X Q naught, which refers to E, is equal to Q naught X Q naught 0 Q naught X Q naught, which is again E, and Q naught X Q naught, which is also E. And this is useless. And now let's move on to this, which is Q naught X Q1, Q naught X Q1, which is F, goes to 0 Q naught X Q naught, which is E, and Q naught X Q1, which is F. There's also 0 Q naught X Q1, which is F, and Q1 X Q1, which is H. And our rest of the production rules are A, B, because Q naught Z naught Q naught and Q naught Z naught Q1 are our start rules. Now our pop functions are Q naught X Q1, which is Q naught X Q1 refers to F. F is also 1. Then Q1 X Q1, Q1 X Q1 refers to H. H also goes to 1, and also it goes to null. And Q1 Z naught Q1 refers to D, which also goes to null. So here we have our final set of productions, which can also be further reduced. So S goes to A slash B. This is our first starting rule. A goes to 0 E A. B goes to 0 E B or 0 F D. Then E goes to 0 E E. F goes to 0 E F, 0 F H, or 1. Then H goes to 1 or null, and D goes to null. Now let's simplify this by removing. How do we simplify grammar? Simplifying grammar is easy. We first remove null productions, then we remove unit productions, then we use lemma 1, and then we use lemma 2. So when we remove our null productions, we will basically be substituting these into where it is needed. So since now we have D is used here and nowhere else, so S goes to A slash B, A goes to 0 E A, B goes to 0 E B, or 0 F because D has been substituted by null. E goes to 0 E E, F goes to 0 E F or 0 F. H has also a null production, so H can be substituted by this, or we can also substitute H by 0 F1, and then we also have a 1 here. So H has also been removed, D has also been removed. So we can remove these productions as well. So these are our null productions removed. So we have already substituted all our um, productions here, and now let's see if we can simplify it further. Now we'll start with our lemma 1, which basically says that if a production ends in a terminal, then we will consider it useful, otherwise we will not consider it useful. So lemma 1, applying lemma 1, we get the following, that okay, let's start with start symbol. So A does not end anywhere, but it starts with A and B. So it is important to keep these in mind. Then B has a production which is leading to 0F, which ends in a terminal eventually. So B is important. But A doesn't have a production which is eventually ending in a terminal. So this can be removed. E can be removed and A can also be removed. Therefore, this can also be removed. There's only one stop symbol. So B is ending with 0EB and 0F. So this is also not going anywhere. So we can also remove this. So basically, B is ending in 0F, and then F is ending in 0EF. Well, again, E is not a useful one. They've already removed it. So this also goes. And F is going to 0F. It is also going to 0F1 and is also going to 1. So this is the final set of productions that we have obtained. Can you see the amount of work we have done? We have done all this and we were able to simplify it into these simple three productions, right? So here we can say that our language is basically comprised of these, and if we further try to simplify it, we can also come to this conclusion: s goes to 0f and f goes to 0f, 0f1 and 1. And if we try to investigate and see what this language is, it basically comes out to be, yeah, this is the final set of rules that we have, final production rules. So B here has been successfully substituted and we will finally come down to two rules. So that is how you can convert essentially a PDA into a CFG and how you can also simplify it. Now let's see for the last step for lemma 2, is it even reachable? So sure, this is certainly reachable, and we have applied all of our production rules and all the simplification rules as well. So this is how you can essentially convert a PDA into a CFG and then also simplify it using removing unit productions and removing null productions, then applying lemma 1 and lemma 2 to obtain something, right? So thank you so much for watching. This has been the entire video. Thank you.